Greetings, class. Greetings. Welcome to CSC560 Operating Systems Week 1. All right, time to pump it up. Okay, we're going to be delving into operating systems, what it is, how it works and that sort of thing. We'll be going over these in detail here in a second. But I just want to kind of highlight that at this point, we're expecting that you have looked at the introduction video. And basically what you saw in week 1 of that video is what we're attacking now with operating systems. So let's do a deep dive. The expectation is you will have looked at this video before our class on Wednesday. On Tuesday, Tuesday, not Wednesday, on Tuesday, so that this would basically be sort of a review, but now we'll be going into a lot more detail to kind of fill in the holes where you didn't possibly get on Tuesday. But you will have a quiz, okay, on this particular video and all videos in the coming week, just as an incentive for you to look at the video. So if you're not in class, you can't take the quiz. If you can't take the quiz, that's a 0. Okay, and that goes towards your participation grade, which I don't really think that you want to basically give something up that easy as far as points is in the participation grade. So, look at the video, come to class, be sure you take the quiz, and then we'll kind of move on from there. Okay, so the week 1 has various items that we're going to be looking at. Okay, in week 1, our focus is understanding the purpose and the roles of operating system, exploring a little history, identifying types of operating systems, and examining operating systems, the architecture, how it's built, what are the major components. And so those are the kind of the highlights of the focus we're going to be looking at here in week 1. To break it down further, we're going to be looking at what is an operating system, roles of an operating system, history, high level. Okay, we're not going to be deep diving into the history. Okay, but just a kind of a recollection of where did we come from. Okay, types of operating systems. Okay, which should be something that you should know. Operating system components, as we mentioned in the focus. User mode and kernel mode. What does that mean? Okay, as far as operating systems are concerned. Modern operating systems, Windows, Linux, Mac, and we'll talk about those. And then we'll have our week 1 assignment review. In fact, that as far as the video is concerned, we really will not be looking at week 1 assignment review. We will be looking at week 1 assignment review in class, okay, in class. So that piece of information here, it is going to be in week 1, but it will be part of our face-to-face. Okay, for those who are online, okay, your assignment is you'll have the video of this and also our review of the assignment. Okay, so that's part of your normal, just if you're online. So So let's go ahead and get started. This is kind of an overview of the individual details. Okay, so what is an operating system? Obviously, there's probably somebody who said, well, I know what an operating system is. But let's get down. Let's make sure we do understand what it is. An operating system is system software, quote, system software. That manages computer hardware and provides common services for application programs. It is an intermediary, okay, acts as a bridge between user applications and hardware. Your program is telling you that you want to do something. You ask the operating system to pass that information on. Operating system does that. That's an intermediary. It's in the middle, okay. Resource manager allocates, controls CPU, memory, devices, files. All of that is the purpose, or is in that what that operating system is. It's a service provider. Okay, it offers a set of services that programs can use. It hides complexity, makes hardware details easy to use. It is basically saying, as we said, I have something I want to do. I tell the operating system to get it, to do it, to save it, whatever that request is. And then the operating system will take care of it. I'm not having to worry about how that's actually done. The operating system takes care of that. And then when we talked about examples of operating system, Windows, Linux, Mac OS, Android, iOS, again, all unique operating systems that are basically working on a certain set of hardware. And that's basically displayed here, where we have the users and applications, interfaces with the operating system. And with that, they're going to interface with the CPU, the hard device CPU, the memory, the storage, the devices. Operating system is that intermediary. That's the most critical thing, the intermediary software that's enabling all of this to happen. Key point here, the operating system manages resources and provides services so users and programs can run efficiently without needing to know the hardware details. If I have a program, I don't want to have to care what's on the other side of the operating system. Okay, what is it interfacing with? Okay. I just need my information saved. I need my information read. I need my information revised or deleted. Okay. I am not really concerned with whether that's on a disk, on a CD, on a tape drive. Okay. Being transmitted over into England. Okay. I don't care. Okay. I really don't care. And so I'm basically looking at the operating system to take care of all of that. Okay, roles of the operating system. Operating system performs many essential roles, ensures smooth and secure system operation. Process management creates schedules, terminates processes, handles synchronization and communication. Okay, that's one of the main process management of all the think of all the processes that are being performed in your computer by your operating system. Your operating system is keeping control of all and every process. So we're talking thousands and thousands of processes that the operating system is taking care of. Memory management keeps track of memory usage, allocates, deallocates memory, and implements virtual memory. We'll be talking about what virtual memory is a little later. File system management organizes files and directories, controls access, maintains file integrity. Okay. And I guess the first thing's going to come, Professor Stedman, are we expected to know all of this in detail? Yes. Okay. Yes, I am expecting for you to know when someone says memory management, okay, that the operating system, what does that mean? What is memory management? Okay, so yes, to that level, I want you to be able to basically remember that from memory. Now, no pun intended. Okay, memory management keeps track of memory usage, allocates and deallocates memory, implements virtual memory. File system organizes files and directories, control access, and maintains file integrity. Device management provides and manages I/O devices through device drivers. So as far as any devices that's connected, the CPU has connection to, and they can be utilized by your program or someone else's program, that device management, okay, is basically in control of the CPU. Excuse me, not CPU in the operating system, but the CPU also. Okay, but we haven't talked about CPU yet. Okay, excuse me. Okay, security and protection protects system resources and data, enforces access control and isolation. Again, part of the duties of the operating system. User interface provides CLI and GUI, okay. User interfaces and touch interfaces for users' interaction. Now, when I touch the screen, what happens? That's basically the operating system that's handling that. Key point here, these roles allow operating systems to manage resources efficiently and provide a safe and convenient environment for users and programs. Okay. And that's the role of the operating system. So we know what it is. We know what the role of it is. A little brief on the history. Not really, don't worry, I'm not going to have something on the history on the quiz. Okay. But all these other three, I probably will. Okay. So again, study those in earnest, in detail. Okay, but the history of operating system, 1940s, 1950s, and you say, wow, do I really care? Okay, but batch systems were jobs collected and run in batches. There was no user interfaces. And then the 60s and 70s, we got into multi-programming. 70s and 80s, we had this concept of time sharing between among systems and programs. 1980s to 2000, your personal computer came into being. 20s to the present, modern and cloud operating systems. When we talk about virtual, we talk about cloud computing. Okay, that's basically in the 2000s. And in the future, AI, assistant. Okay, AI is going to be the future, and we need to be ready for it. Okay, so okay, so key point here, operating system evolution reflects advances in hardware, advances in users' need, the drive towards more powerful and interactive and intelligent systems. How intelligent that gets is dependent on the operating system. So when we look at AI and we look at what it can do, the key thing that makes it work is the operating system and how it interfaces with the rest of the world. Okay, types of operating systems, different operating system types. We got batch OS, jobs processed in batches without user interaction. Time sharing operating systems, real-time operating systems, distributed operating systems. Distributed manages resource across multiple interconnected computers in a single system. I got 5 computers. I'm talking to each other. Okay. I need to be able to coordinate that through the operating system. That's basically done with distributed OS. Network OS provides networking services as file sharing, printing services, user management. Mobile, designed for smartphones and tablets and Androids and iOS. Embedded OS, use dedicated systems like appliances, cars, that sort of thing is basically operating system. It's listed here, but think about your car. Cars are so advanced now that each car, in essence, has an operating system. Okay, so we're looking at basically the number of things that utilize an operating system increasing, multifold by multifold. Key point, each operating system type optimized for different environments. Basically what I just said. I'm going to optimize my operating system if I'm in a vehicle. I'm going to optimize my operating system if I'm using my iPhone, my tablet. All those operating systems are basically optimized based on the hardware that it's going to be running on. Okay, so each operating system type optimized for different environments and workloads. Okay. Okay, so the next thing, operating system components. What are the pieces? What are the components of an operating system? The operating system is built on several components. We have the kernel. The kernel is the core of the operating system, manages resources, processes memory, and device communication. Without the kernel, nothing works. The shell and command interpreter provides a command line interface for users to interact with the system. Graphical user interface, GUI, allows users to interact using windows, icons, menus, pointers, buttons, all that good stuff that we put in online systems. System libraries is collection of functions and routine used by applications and system programs. Many times they're the services that can be called. Device drivers, specialized programs that control I/O devices and provides a uniform interface for the operating system. System utilities, programs, file management, diagnostics, performance, monitoring. this operating system that we're talking about does a lot. It does a lot. And again, the reason you're taking this course is to get an understanding of, what's involved in that. What are the details of that? So that's why we're going through this. So you'll know the pieces, you know what it does, you know the components, if I have a failure at some point, why did I fail? What did the operating system do or didn't do, okay, when that failure occurred? All of this is basically putting that in perspective as far as understanding what the operating system does. Okay. Here at the bottom, we're talking about, applications, which is what we're writing for this, telling what we want to do. With that, we're going to have to probably access system libraries, which have different types of information or standard routines that we need in order to do something. We have the device drivers that says, okay, if I'm working on a printer, okay, I'll have a driver that interface between the printer and the operating system so they can communicate. And going down to the next level, I'm going to have multi-drivers because as I have multi-printers of different types, different manufacturers, each one is going to have its own individual driver. Okay, so not only does the operating system have to worry about a driver, it has to worry about multiple drivers so that it can interface with multiple models. Okay, so drivers, kernels. Okay, kernels, as we said, was the core, and then we interface that with the hardware. The key point here is these components work together in layers, okay, to provide seamless interaction between users, application, and hardware. Okay, we have two modes. We have the user mode and the kernel mode. The user mode applications run here, limited privileges, cannot access hardware directly, request services via system calls. You are the user. I am the user. We're on this side of the fence that says, I'm running my program and I'm going to ask for certain resources in order to interface with various hardware components. Okay. And you see here the system call, okay, is a request. That's how the user, I'm in user mode, that's how I get things. I call to make that request. In kernel mode, OS kernel mode runs here, full privileges, can access hardware, resources, handles interrupts and exceptions. Okay. The kernel mode returns the request that you made on the system call from the user mode. So I go from user mode back to kernel mode, and once I get the answer, I send that information back to the user. Okay, so that's user mode and kernel mode. One has access to everything. All it has access to is a call request. Okay, mode switching, a program in user mode makes system calls. CPU switches to kernel mode, executes the service. That's basically what we said. Operating system completes the operation, returns control to the user. The reason we separate the modes, okay, protection. User programs can damage and cannot damage an operating system or other programs. Think about programs that you have written, okay? Those programs most likely have had problems. They have had issues, okay? We don't want those issues to affect the operating system itself, which controls the entire computer. Okay. When you basically, have a problem with one of your programs, you make a call. Okay, all the critical resources is not a place where you want your program to have access to directly. Okay. So that's why we have two modes. One being the user, we call, we get a response back, so that we don't have everybody's program manipulating the key resources of the operating system. Okay, reason for mode separation, that's down here, basically what I said. User cannot damage the operating system, prevents crashes in user programs from affecting the operating system, restricts access sensitive to hardware and data, okay, and reliability, ensures orderly and controlled system operation. With everybody doing something with an operating system, it's basically chaotic, okay? And we can't let that happen. That's why there's a separation of those between user and kernel mode. The key point here, mode separation ensures protection and stability by restricting privileged operations to the kernel. Okay. Modern operating systems, okay, these are ones that we probably most of us know about. Windows, widely used desktop OS, Linux, Mac OS, Android, iOS, embedded IoT OS, lightweight operating system dedicated for devices like appliances, your car, your refrigerator, okay, your stove. Okay. Those are the embedded types of operating systems that are built in. Trends toward operating system, virtualization, cloud computing, mobile computing, and then, of course, AI, which is coming down the road. Key point, modern operating systems continue to evolve to meet demands of new technologies and user expectations across new devices that are coming through and new environments this has to have controlled. Okay, that's it for week 1. Got more weeks and we'll have some fun in learning about other parts of the operating system. Go over your homework, look at it, write down any questions, and I will see you on Tuesday, okay, for the first class of week 1 for under operating systems. Have a good one, everyone. Bye.